welcome back to this Synthi 100 repair. I've carefully connected the mains to this power supply. I'm running it off the light bulb meter, and I've got an 8 ohm resistor plugged onto its output, and including the sense wires going to the resistor as well. So this is an 8 ohm resistor which will be running about 1.5 amps. When I ran it from my bench power supply, it was pulling 2 amps, so this is just a little bit under current. So let's switch it on, and now you can see the ripple. Looked a bit more pronounced when it was connected to the synthesizer, and we're reading minus 10 volts. Pretty sure that it was more like minus 12 when it was in situ. So let's see what frequency this is. 3.2 kilohertz. So it's unlikely to be the bridge rectifier, although definitely might be worth changing that anyway. Okay, at least we know we can replicate this on the bench and start to have a look at what's inside this power supply. Interesting to see what voltage we have across this massive cap here. Hang on, let's see. Oh, no, nothing to write home about. So if we have a look inside, if we have this massive capacitor here, some taps from the transformer. There's a capacitor down there. And there's the bridge rectifiers, by the looks of it. And this must be the regulation board. And it looks like there's only one electrolytic on there. And behind the transformer, we have some sort of transistor. Okay, so let's have a look at the caps, I guess. Monster, 10,000 microfarad, 50 volts DC. Ooh. Didn't like that. In-circuit leaky. And we've got this awkward little cap down here which seems to be glued itself to the bracing here. I've got my replacement caps ready. As you can see, this new Nichicon cap, which I think is an upgrade, is a lot smaller, but it is rated for 5 amps ripple current and we're only pulling 2 amps. So I went for quality over quantity. I've got a new bridge rectifier, which I'm not really going to be able to film swapping this out because I don't want to make any mistakes. But after the vocoder video with the bridge rectifiers going wrong, it's got to be done. Okay, so I've got the basic connections in for the bridge rectifier. There's just two components. This resistor is a 1K which goes across the DC output, and that's measuring fine. And there's this 100 nanofarad which goes across the AC input, and that's measuring fine. And these components I don't think get put under any stress, so I'm going to use these, put them back in. I don't like any of these little nicks in the heat shrink, so I've been suppressing them as we go. Okay, that's the bridge rectifier back together. We've got the positive there, negative there, black and red are going to the filter capacitor, blue, and this green one goes to the transformer. So that's all looking great. Okay, we got a brand new ridge rectifier. Okay, we're going to stick this one back in now. This is the one that got stuck. Not very clearly labelled. Black went to this one here. Red one would presume that it was the positive terminal, but we can quickly check that. I connected to the negative there. So if this beeps, okay, so that is negative. Okay, we've got a bit of a problem here. A couple of places where the capacitors go have disturbed the traces, and I noticed a short. So under the magnifying glass here, you can see that it looks like that trace is supposed to go all around and join up with that other trace that is broken. So I'm pretty sure that's how it's supposed to go. Okay, so I've just got the capacitor dangling there at the moment. I just want to see, there's no point spending hours trying to figure out how we're going to secure that. See if it works first. So I've replaced the bridge rectifier, all the caps on this board, the main filter cap. I've repaired the traces that got broken when taking the caps out. You only had to look at those traces in a funny way and they just fall off, so that's really tricky to work with. Okay, so I've set back up the experiment. I'm powering from the light bulb current limiter in case it all goes wrong, and I've got my 8 ohm load, which is a little bit less than the Synthi 100 is expecting, but before we saw the ripples, so that was good. This is going to be monitoring the voltage, and I think it was at -10 on the first inspection. And of course I'm probing the scope now to see if we get any ripple. So fingers crossed, let's see what happens. Wow, so that's now at -12, which is fantastic. No ripple at all. I am happy with that. Now that is definitely the best outcome that we could have had there. I was almost toying with the idea of putting a couple of switch mode power supplies, but EMS have actually tried those experiments and they didn't turn out so well. So the fact that we could get this original one back up and going is absolutely fantastic. Okay, and the great news is this capacitor housing has a hole in there, so I'm pretty sure I'll just be able to cable tie this in. So I'll put this back in. Okay, so the capacitor is nicely in there now. Let's see if we've broken anything. .96 volts. We can adjust that when we put this back into the Synthi. And if we have a look around, nothing's getting hot at all. Even with this 8 ohm load. So that's all looking extremely good. So if you like that video, please subscribe, and in the next video we'll see if we can put this back into the Synthi and everything should be okay again. Catch you next time.